Good morning, sir. My name is Guan Jiaxian, and now I represent the Smart Power Implementation System. This is our group, and now I represent the Smart Power Implementation System background. Why this Smart Power Implementation System will appear is because the palm oil is one of the world's essential edible oils, and the way the traditional production method will cause the damage to the environment and waste the resources. The smart oil prediction system will optimize the prediction and management using the IoT, AI, and big data analytics to reduce the environment impact. And they use the sensor and monitoring device to collect data related to the soil humidity, weather condition, and the crop growth. We are using the remote sensing technology. For the history, this smart point prediction system is represent a shift in agriculture practice to meet the sustainability and efficient needs of the palm oil industry. The traditional predictions is rely on the manual labor. For example, the worker using the traditional tools to collect the palm, like the knife, long knife, or no use the any machine. The only use their basic agriculture technique. But rising global demand for palm oil and environmental concern for now, there is already need to require the modern solutions. For the intelligent system enable real-time monitoring, data-driven decision-making, and proactive innovation to increase the production and reduce resource consumption and environmental impact. For the future frame of smart power prediction system, the first one is the advanced sensor combined with the AI and machine learning algorithm. This is the way for data is collected and analyzed, providing real-time insights. And the second is the integration of renewable energy resources such as the solar wind and the biomass. This will reduce dependence on fossil fuels and reduce the carbon emissions. And for the blockchain technology, it will enhance trustability and transparency to increase the consumer trust in palm oil sustainability and drive industry compliance with the sustainable standard and the ethical practice. Why need the blockchain technology is because they can record the process production of the palm oil, including the picking, plantations, transportation, and the last process about the palm oil. So that is why I need the blockchain technology. So that's all for my presentation. Thank you.
Hello, sir. My name is Goh Junyong. My student ID is 20ACB02621. I will present the problem statement of this project. In this study, the first problem is owners often find themselves physically visiting their palm tree farms to ensure the well-being of their trees. Traveling to the farm, inspecting its trees, and assessing its health takes its toll, both in terms of energy and resources, while some owners option to hire managers to oversee the farms. This also comes with its own set of challenges, including cost implications and concerns about the integrity of human involvement. The second problem statement is owners manage multiple farms spread across different locations. Coordinating and maintaining effective communication channels become paramount. Without real-time insights into each farm's operations, ensuring consistency in management practices becomes a daunting task. Efficient resource allocation across various farms requires accurate data on each farm's unique needs and performance. The third problem is owners face challenges in promptly identifying and addressing issues that affect palm tree health and oil production without the aid of real-time monitoring and control systems. Relying solely on periodic visits may overlook sudden changes or problems that require immediate attention. This lack of real-time information can hinder the implementation of timely interventions, potentially resulting in losses in productivity and quality. Next, I will present the objectives of this project. The first objective is to remotely monitor the environment of palm tree areas Our system can be established utilizing sensors that measure weather parameters such as soil moisture, temperature, humidity, and light intensity. This sensor can transmit real-time data to a centralized platform accessible via web mobile. With this system, palm trees can be easily managed no matter where the owner is. The second objective is owners can easily manage all palm trees in different areas or state. Our system offers features such as geolocation tagging, allowing owners to categorize and track palm trees based on their locations. By enabling streamlined management, owners can allocate resources effectively and prioritize maintenance tasks. The last objective is provide owners with daily and weekly environmental information about the palm tree via SNS notification. This notification can be tailored to deliver concise summaries of key metrics such as soil moisture levels, temperature fluctuation, and pest infestation alerts. By leveraging platforms like SNS notification or Amazon QuickSight dashboard, owners can conveniently access updates on the go, timely interventions to ensure the well-being of their palm tree.
My name is Yosin. I'm going to present study of different IoT platforms in this presentation. AWS IoT is a comprehensive platform for building IoT applications that provides tools for device connectivity management and data analysis. It is known for its robustness, scalability, and seamless integration with other AWS services. Then the Cisco IoT Cloud Connect offers connectivity solutions for IoT devices, leveraging Cisco's strong networking and security capabilities. It is more focused on connectivity rather than complete IoT application development. Then move to the Oracle IoT Device, a full suite of service for IoT system development and management. Integrating with Oracle Cloud Infrastructure and Analytics, it is scalable and supports deployment in both edge and cloud environments. Then the table shows the comparison of service provided by these IoT platforms. From the table, we can realize that AWS IoT have a potential that it offers a more complex service than can work with others AWS cloud service. While Cisco IoT Cloud Connect is more focusing on the connectivity for IoT device because of Cisco is a networking company. Oracle IoT also provides various services that work with Oracle Cloud Infrastructure. This is the end of my presentation. Thank you.
Good day, Dr. Michael. I'm Daishao from Group 26, and now I'm continue to present our architecture diagram. So this is our architecture diagram for our proposed system. In this system, we'll use 8 major of the AWS services. The first will be the AWS IoT Core, used to collect the sensor data from the real world and send it to the cloud services. AWS Amazon DB will use to store the data from the sensor passing by the IoT core. We will use 2 Amazon S3 buckets. One is used to store the raw data from the sensor in order to use for future use. And then another one will use to store the image passing by the IoT canal. And Amazon recognition will use to recognize the mutual plum oil by send a data set of the images into the system and then training it and modeling it. In this system, Amazon SNS will use to send notification to the user when the sensor data detected are not suitable for the environment growing to the palm oil tree. And when palm oil mature, it will send alert message to the SNS. In order to make the system smoothly passing the data, we will use Amazon AWS Lambda. We use to trigger the data to the AWS recognition and SNS. Now I will proceed to do the demonstration. The first thing we need to do will be create the IoT core. So we go to the all device, select the things. After that, we create the things, make it all default selection. name it the IoT things. Next, auto generate, and the policy we will use current I selected one. In this selected one, I will select effect select all allowed, action select all, and resources select all. Next, we will create the things. Then after that, it will pop up this message. We need to download the device certificate, public key, private key, and root CA. After downloaded, click done, and we have done to create a things. And now we will go to the DynamoDB, create a table, name the table. So enter the partition key, we will select location, and we click create table. In this time, node rep will represent our sensor camera. So now we go to the AWS IoT core, go to setting, copy the endpoint, and the certificate, public key, private key, and root CA downloaded before we use on here. Localhost will paste the endpoint of the IoT core. The port number will use 8883, use TLS, and under TLS configuration, click it and upload the certificate, private key, and root CA downloaded before. After done, uploaded and name the topic, click done, and now we have successful setting the IoT camera, DynamoDB, and the IoT thing. Now we go to the rules, create the rules, name the rules, and for SQL statement, we will use select all from the topic we are created just now, data test, and click next. Choose an action we'll use for the Dynamo, and remember to select the split message. Choose the DynamoDB we created just now, maybe like this. Choose unroll. Remember to give the permission about the DynamoDB. After this, click next, overall. If no problem, click created, and now we click pass data. The test one, explore data item. And now we are able to see the data now. And now we have successful connected with the IoT sensor, AWS IoT core with the DynamoDB. To check its work or not, we go to the IoT core MQTT test client, enter the topic, click subscribe, we pass the data, and the IoT will receive the data from Node-RED. And we go to this DynamoDB. Inside the DynamoDB, we can see the data is inserted in the database now. And now we proceed to the SNS with AWS Lambda. So for SNS, we'll go to the SNS, under topic, create topic, select standard, name the topic, and others, we'll keep it as default setting, create topic. And now we create subscription, the topic ARN, and the protocol, we'll select email and enter the email and click create subscription. We'll receive the AWS notification and click confirm subscription, then confirming, yep, the subscription confirmed. Then now we have finished our SNS part. And for the AWS Lambda, click create function, name the function, and click create function. Once finished, create. Under configuration, permission, remember to key in AWS Lambda permission, CloudWatch full access, DynamoDB full access, and then Amazon SNS full access. And now you can add trigger. Select source will use DynamoDB to pass the data from DynamoDB. Select the DynamoDB just now. And now you have done the setting up the Lambda function, and now you can doing the coding part to pass to trigger the data to the SNS. So this is the coding to trigger the message to the SNS when the humidity is lower than 60 or higher than 80, and the soil pH lower than 5 or greater than 7 will trigger the alert message to the user through SNS. And now we have done the branch of the passing sensor data for the SNS. Now I will demo the IoT things camera, capture the image, store in the S3 bucket, use AWS Lambda to trigger the Amazon recognition and SNS. So to create the S3 bucket, we'll just create bucket, general purpose, give the name to the bucket, and or keep it as default selection and click create bucket. Once created, we'll display on the bucket table. And now this is the code that we stimulate as the camera. The next step will continue as the Amazon recognition. We go to use custom label, project, create the project, name the project, and now we can create data set. Start with a single data. Select the import function that you want. In this case, I will use import image from S3 bucket, and then the S3 bucket URL. After this, click create dataset. Once finished, create the dataset, we add label to the image, and this is the images that I import before, and I have label as the Harvest and Henry. Once finished the label, it's supposed to have a train at here. You need to click the train. It will take some time to train the recognition. Once finished, the model status will set as the training completed, and then you click use model and click start, and you are starting to recognition now. For SNS, we'll just use the previously created one. Before that, we need to create a lambda function. So for the lambda function, under configuration permission, you need to give permission as the Amazon S3 full access, Amazon recognition full access, CloudWatch, and then the Amazon SNS full access. Once finished, add trigger, select the S3 bucket that you store the images from the sensor IoT camera, select the bucket, all object create events, and add, and click add, and it will display here. Now you can do the coding of the lambda. The lambda coding I will use is when it detected labels include the fruits, which means that the palm oil is nurtured. It will send the notification through SNS to the user. Now we try to do the demonstration. We run the not JavaScript file to send the image to the S3 bucket, uploaded successful to the S3 Amazon. And we refresh. Yep, we receive the location file, JPG. Then this is the image we pass to the S3 bucket, and it's the image of the nutrient palm oil. And now we go to Lambda, configure, and monitor, view CloudWatch log. So it is detected as fruits, which means the nutrient palm oil, and it will trigger to the AWS Lambda and send an alert message to the SNS, which are the location file of the palm oil is nurtured. Yep, receive the email. We will also receive the email when the environment is not suitable for palm oil-free row. Yep, we will receive the AWS notification message from through SNS. Due to the sensor detected the humidity is lower than 60. Now we will proceed to Amazon antenna. And before we proceed, and before we go through the antenna, we need to create the S3 bucket. So in this case, I have created call inputs. Inside that, you will have the selected CSV, which is our raw data of the sensor captured from the DynamoDB. And this is the sample data we store in the S3 bucket. And before we proceed to antenna, we also need to create one empty S3 bucket. I have created call outputs. And now we go to the antenna, click create workgroup, enter the workgroup name. Under the query result, we need to put the location that we create the empty S3 bucket just now. Just now we created output, select it. After this, create workgroup. Once workgroup created, go back to the query editor, select the workgroup that you have created just now, give a name to the table, and you can select create a database or choose an existing database, up to you. Dataset will select the S3 bucket that we have stored the raw data from the sensor. And the file type will select CSV file. After that, for column, based on your dataset, enter the column that you have. In this case, I have 5 columns. Once finished, we can preview the table query. If not mistaken, click create table. I've created before, so we preview the table. Yep, completed. And this is the table that this is the data we queried from the S3 bucket, and it will store at the outputs S3 bucket that we created just now. Once finished the query data from S3, we go to the quick site. And before we proceed to import the query data from antenna, we need to go to our manage quick site under accounts, under security permission, manage. Remember to select the S3 bucket and select the S3 bucket at the output, which means the query data extract from the antenna just now. So now we go back to quick site, click new analysis. New dataset, select antenna, enter the name, antenna work group you created just now, and select the database created just now. Select it, edit and preview. So this is the query data that we extract from the antenna. And now we can change the data type, like postcode, and the date will change to the date. If there is no mistaken, click save and publish, and click publish and visualize. Now you can create the QuickSight dashboard now.